Welcome everyone to today's Power Hour presented by Standard Motor Products. My name is Donald Harrison. I've been with the company a little over 10 years now. For a majority of that time, I actually manage the Hayden Automotive transmission cooler line, and that's our subject for today. We'll be discussing transmission coolers, their benefits, their construction, as well as what they can do for you and your vehicle, as well as maybe some installation tips. So why don't we jump on in here? Transmission coolers really started in the aftermarket in the early 1960s. Perry Hayden first took his 1959 Chrysler Imperial out to the mountains so he could go camping with his family. After 2 or 3 trips, he'd have to get his transmission rebuilt. It would start slipping. Not satisfied with this happening, not wanting to pay for it, he started looking for a solution. That's when he took the old condenser off the back of an old refrigerator he had, modified the lines, and installed it behind the grill in his Chrysler Imperial. In doing so, he cooled the fluid, and lo and behold, he no longer had to buy any more transmission rebuilds. Like most camping buddies, as soon as they saw what he was doing, they said, "Me too, make me one, make me one." Next thing you know, here we are in the automotive aftermarket with transmission coolers, solving problems for cooling for those that need it. So this brings about the question, why do we cool the fluid? Well, as you can tell from our temperature chart here, if we can keep our fluid in that 175, 180 degree range, it lasts a long time. It'll get 100,000 miles before the fluid really starts to break down. But every time we add 15 to 20 degrees of heat, notice how the mileage life cuts in half. Especially when we get over 300 degrees, that transmission oil is just not designed to last that long. A lot of OE coolers and OE setups use the radiator fluid from the vehicle to cool the transmission fluid. Well, the problem with that is you're now relying on 230 degree coolant to keep 300 degree oil cool. It just struggles. It just can't do a very good job. And that's one of the challenges today, and we'll go into a little more depth here in that in a moment. Now I'd like to talk about the 3 cooler construction types. We're going to go over nested plate coolers, plate fin coolers, and tube fin coolers. Each of these has their own advantages as well as their own drawbacks, challenges. First is the nested plate cooler. You find this on a lot of SUVs, trucks, anything with a CVT typically has a nested plate cooler. It's a liquid to liquid cooler, and it typically will have 4 ports. 2 will go in for the oil, 2 for the coolant. Now, this does a fantastic job because it's small and compact, right? Automotive manufacturers can put it under a bumper, stick it anywhere on the side of the transmission, similar to our Subaru CVT here. The drawback, though, is they really don't do a great job cooling in the hot summer months, especially in the southern climates. As we talked about earlier, that hot coolant doesn't do a great job cooling when it's warm outside. Another cooler construction type we have is our plate fin, or is our tube fin. Tube fin coolers are robust and rigid. These are a great economical solution that can provide a long life of use and take a beating. And these are great, especially on off-road vehicles where a rock or other debris may fly up and hit the cooler. The fins do a great job of protecting the tubes where the transmission fluid flows through. Our third and final design is actually our plate fin cooler. Plate fin coolers are great because they're more efficient than the tube fin by size. Their compact design allows them to be mounted, again, anywhere where there's good airflow up front, in a front bumper, underneath the hood, where there's a fan, anywhere that it can really get good airflow, a plate fin will really shine. Now that we've talked about the construction types, let's look at some of the internal and how these coolers work. We're going to go over laminar flow, what that is, why we want to break it up, as well as what's inside and why it matters and why that counts. Laminar flow. This is an effect where the fluid is only cooled along the edges. As the fluid passes through that tube, the air rushes over it and it draws the heat out. However, the outermost edge of the fluid insulates the innermost. You've probably experienced this if you've ever pulled out a meal out of the microwave and taken the first bite and it was screaming hot. And then over here on the other side, the next bite was ice cold. It's kind of the laminar flow effect, very similar, right? The fluid in the center of the tube is still super hot while the outside is getting chilled. So we need to break that up, right? Because if the inside is still hot, as it flows, it's diminishing the efficiency of the cooler. This is why we really need to mix the cold with the hot so we can greatly improve the efficiency without having to put a cooler the size of this table underneath the hood. Laminar flow is most commonly disrupted by just changing the passage size or, basically introducing what's called turbulent flow. Turbulent flow is where we want to swirl the fluid. Think of mixing. We want to mix that hot fluid with that cold fluid, so that way the cooler has a chance to remove as much heat as possible from the fluid before it's returned to the transmission. Now, this can be a challenge, right? Too much turbulent flow, and it can drop the velocity of the fluid and create a problem. But if we don't turbulent it enough and we allow it just to flow right on through, then the laminar flow effect comes into play. And then we end up with not efficiently removing the heat, thus the cooler's not doing its job and the transmission suffers. This is where we have to find that right amount of balance between just enough flow, but also disrupting it with some turbulence so we don't starve any of the components in the transmission. Inside our tube fin cooler, we actually have what we call a turbulator. This is a patented design. And what it does is it swirls the fluid as it goes through the tube, thus introducing that turbulent flow to help maximize the efficiency. As that fluid kind of swirls through the passages inside the tubes, it does a great job and allows it to be more efficient. Over on our plate fin side, the tubes have been squished down into a flat package, so we can't exactly introduce a swirl inside them. Our engineers, again, came up with a patented design where they introduced dimpled plates. These dimples allow the fluid to cross direct around. This helps mix it up while also minimizing the pressure drop so we don't starve those transmission components. All of these have been scientifically engineered, calculated to maximize the cooling efficiency while not creating a pressure restriction that could starve your transmission, pan, pump, or cause other failures within the system. Now that we've talked about the construction types and their advantages, now we're going to look at some of the units of measurement and what that means for the transmission, for the coolers and calculating them. Flow is the gallon per minute, or pressure, PSI, and how they're related or not, as well as cubic feet per minute, which is the air. That's the critical component whenever we're talking about these tube fin, plate fin coolers. And then finally, we'll get into BTU, which is British Thermal Unit, which is kind of the measuring stick for how we gauge coolers, and they're to compare them apples to apples. First, I want you to look here. You've got two different flow streams here. You've got a garden hose with a decent gallon per minute flowing. There's no restriction there, right? The end of the hose is wide open and it's flowing. Now, if we had the same size hose on our pressure washer, notice that there's a restriction. What this restriction does is it reduces the flow, but greatly increases the pressure. This is important to remember when you're considering selecting a cooler for your transmission installation. If you pick a cooler with too small of a passage or port, it can create a restriction which can drop the flow and cause damage to the system. If you pick a cooler that's got too large of a port, or non-restriction, the fluid will actually lose its velocity, which then can create damage to future components as they starve for fluid. Here on our F250, we've removed the grill so you can easily see. Now, immediately you're thinking, hey, I got to replace the transmission cooler. Bam, there it is right up front, right? Got it, order it, let's go. Not so fast. This is why it's always critical to look at OE service and aftermarket service information. This is actually the power steering cooler. Our F250 diesel here actually uses a nested plate cooler design tucked away underneath the bumper, where it's nice and compact, out of the way, and it uses the secondary cooling system built into these Ford F250 diesels. Now, this is why it's always critical. Make sure you look at the OE and aftermarket service information. This will help you select the right cooler, the correct lines that you may need to replace, as well as the correct sizes to ensure you get the proper part to do the repair right the first time. So, as we saw in that F250, the power steering cooler was right up front. This speaks greatly to that CFM component. We want to make sure we get good ram air right up front. Ram air is king. We got to get good airflow going to that cooler so that way it can draw out that destructive heat from the fluid to protect the system and the seals for longer. Now, a lot of times, hey, if the cooler's leaking, we just want to slap on a new one and let it go, right? Get it out the door, go on to the next vehicle. Well, not so fast. It's always a good idea to ensure you can figure out what caused the failure. Maybe some road debris contacted it. Maybe there's a shroud missing. Maybe there's a fan blade bent, broken, or maybe the fan's not even working. There's a lot of reasons why you replace a cooler, and it's always a good idea. We always promote, find the root cause of the problem so you're not just throwing parts at it. A lot of times, if a cooler, you're adding one, and you don't have room up front, you can consider one of these options where it has an electric fan bolted to the side of it. We call those remote coolers. They're a great addition that you can put on your vehicle. It allows you to mount it anywhere, up under a bed, maybe next to a transmission. Always tuck it up and out of the way. That way it's safe and protects your investment with your cooler and can also ensure you get the right amount of cooling, maybe additional cooling you need somewhere else in the vehicle. That really covers the CFM. Now we're going to move on to British Thermal Unit, or BTU. This is what I consider really to be the measuring stick. A BTU is defined as the amount of heat required to raise 1 pound of water 1 degree in 1 hour. From there, you look at the specific heat of transmission oil and you calculate out how much heat you need. Now, transmission coolers can range anywhere from 5,000 to 30, 40,000 BTU. Really just depends upon the application. But this is what allows us to compare apples to apples to make sure you can select the right one. As CFM, gallon per minute, pressure, all those are variables that can change the BTU rating of a cooler. So it's always critically important that when you're trying to select the correct cooler, you look at not only the BTU, but how it was calculated. What was the flow rate? How many gallon per minute? And how much CFM is going through that? It's unrealistic to just jam 40,000 CFM through a cooler, but you can get phenomenal numbers when you do. This is why I consider it a good measuring stick, because it gives you kind of that ability to give a good apples to apples comparison between the different cooler types, construction types, as well as from different manufacturers, so you can get the right cooler for your vehicle. Now we're going to move on. These are some common FAQ questions we get either through our tech line or product teams, maybe common questions you might have. Happy to address more you may have at the end, but right now we'll go over some of these. What cooler should I pick? Where's best to mount it? Do I do it before, after the OE, or do I just remove the OE? Maybe you want to flush it while you're doing the installation since you're flushing the transmission. And what hose should you use? First of all, always going to recommend install the largest cooler you can fit within the area. Make a template, grab some cardboard, grab some old sheet metal, whatever you need. Ensure you can fit the largest cooler in the space available. This ensures you're going to get that little bit of extra cooling. If you remember from our temperature chart, the closer to that 180 degree you can get, the longer that fluid's going to last and the better it's going to be for your transmission. Anytime you do an installation like this, it's always wise to make sure that you route all your hoses away from any moving parts as well as any heat sources. Can't tell you the number of times we've seen a hose melted because it's too close to an exhaust manifold. Don't let that be you. Another tip for installation is the ports on the cooler. Commonly we get asked, hey, what happens if I point the ports downward? Isn't it air going to get trapped in there? Short answer, don't worry about it. The transmission operates at a much higher pressure. The fluid flowing through will push the air out. You'll be just fine. My personal recommendation, I recommend pointing the ports either to the left or right side. And the theory here is your inlet hose coming in with the fluid goes to the top. Your outlet hose, returning the cool fluid, goes back to the transmission pan. This way, the next time you're servicing the transmission and draining that fluid, it'll drain the cooler as well. Getting that little bit of extra fluid out makes you feel those warm fuzzies when you're doing the service. Highly recommended. Where are you going to put the cooler? You know, a lot of people, again, ram air is king. Get it up front. That maximizes that CFM, that airflow coming through the cooler, which can really help. As you move back to the second or third position, you diminish the cooling efficiency by 10 to 20% with each step. In front of the condenser is best, behind the condenser is second best, and if you had to, behind the radiator is probably third best, but again, you could see up to only about a 60% of the maximum cooling capacity. Highly recommend. Number 4 in this diagram shows you your remote option, where you could actually mount it with a fan, you know, if you're going to do under a fender next to transmission or under a bed of a pickup, wherever is best for you. Next, we're going to talk about where are we going to put do you remove the OE cooler? Do you put it in front? Do you put it after? This is where it's important to realize we can actually use the best of both worlds here. You put it after the OE cooler, then you get the benefit of that faster warm-up time from the nested plate cooler, as well as the added advantage of cooling in the hot summer months from being after. Of course, some people, you may have a leaking OE cooler, and that's fine. If you want to remove the OE and just install the aftermarket cooler, that's fine. We recommend in those situations going up at least one size, if not 2. The added size is going to help add to the added capacity that is lost from losing the OE nested plate cooler or internal transmission cooler. Why can't I flush it? What do you recommend? Can I flush it? Should I? It's highly recommended to flush it, right? It's wrong. It's not. Flushing a plate fin cooler is next to impossible. It's kind of like our condensers. If you've ever done AC work, replace them. Those small passages, they get the particulate, they'll get the metal shavings lodged in there, and then you're putting whatever new transmission you put in at risk from those dislodging and coming out and tearing up your brand new transmission. Tube fin, you might get away with flushing, but at the end of the day, it's such an economical part. Why would you risk thousands of dollars in transmission repair over a cooler that's less than $100? At the end of the day, protect your investment that you've made when you replace the transmission by just replacing the transmission cooler. It's cheap insurance, and a lot of large transmission repair shops, they actually won't give you a warranty unless you replace with an aftermarket liquid air cooler like our tube fin partner here. They do that because they recognize the value that a transmission cooler can bring to helping protect that investment that you just put in the vehicle. What hose should I use? Use the supplied hose. Hayden goes to a lot of trouble and time testing and ensuring the proper grade hose that's rated for petroleum-based products, so it's not going to wear out, burst, fall apart, split on you. Don't just grab whatever is convenient. Far too many times that someone will run back in the shop, they'll grab some fuel hose, maybe they grab some radiator hose, something different, and slap it on there. It may last for a little while, but why would you risk it? You spend thousands of dollars on a transmission replacement, don't cheap out on the hose. Get the appropriate hose. We offer several other pieces. Every kit comes with a 4-foot piece of hose. If you need more, please order it. It's good quality and it's going to help protect your investment a little further. Speaking of hose, I want to talk about installation whenever you put hose in. It's important to think of a 12-inch coffee can. If you wrap that hose around a 12-inch coffee can, that's a 6-inch bend radius. That's ideal to ensure that we don't kink the hose. Remember a pressure washer example. If you create a restriction, you greatly increase that pressure, but you drop that flow, that volume. And when you drop that volume, you can starve your pump and create other problems inside your transmission. So it's always recommended, use our quality hose and make sure that you route it safely away from hot or moving parts and do smooth flowing bends. Don't put a sharp 90. Don't try to go around an edge of sheet metal. That's just asking for trouble. Want to recommend everyone visit our YouTube page. Subscribe. We upload new videos all the time. It's a great resource with a lot of little how-tos, tips, tricks. If you have any suggestions for videos, please kick them over to us. We'd absolutely love to have them. Your feedback is always appreciated. Another great resource, standardbrand.com. We're constantly uploading new videos there as well. There's technician resources. There's also a wonderful catalog for all your aftermarket needs. You can look up whatever product you might need and where to get it. Another fantastic resource that I can't recommend enough is going to be haydenauto.com. haydenauto.com is our resource for coolers. We're going to have all the technical specs, the sizes, the port sizes, when you're selecting the correct one, as well as other accessories and fittings to help make your installation go a little smoother and a little easier. Also, on the website, we have an application guide. For vehicles where we've applicated parts, we're going to recommend a small, medium, or large cooler, depending upon your climate where you live, as well as your needs. Maybe you tow, maybe you just have the wife and kids in the car. Either way, we can make a recommendation for the right cooler to fit your vehicle to meet your cooling needs. I'd like to, at this time, thank everyone for coming. I appreciate any sort of feedback. Corey, do we have any questions or comments?
I actually have a couple of good questions. One of them even comes with it's kind of a comment plus question. So the comment is on our transmission coolers, like what's right in front of you and what was on the Subaru.
Yes.
If this is a customer who actually had a situation where they had the lines come off and there was a massive, obviously, transmission fluid leak.
Okay.
In that case, should they replace just the line, or is it possible that because the line was disconnected for a period of time, debris may have gotten into that cooler and it's suggested to replace the cooler? Because what they did is they replaced the entire setup just because they were a little worried about it. But should that be their process going forward?
Anytime you think debris may have contaminated it and you cannot remove the whole line itself to flush and ensure it's clean and clear, replace it, right? I mean, it's cheap insurance to ensure that transmission is not going to get debris sucked inside, contaminate anything, and make you have to go back and do the work again. So,
yeah. All right, perfect. I think that's where this user was going with it, was they just said, you know what, I don't want to take the risk. And then the next question is, and this is actually, I think, a good question. We were talking about it before the call, is when you were talking about the remote located fans, and you mentioned even under the bed, something like that. Is there a preferred or a better angle to mount that? Or should it be flat, flush, angled? Which direction would you consider to be the preferred way of mounting that?
That's going to depend upon the individual setup. Ideally, if you are just looking for maximum cooling say it's a performance application, you want the best cooling possible, I would use a setup where the fan is actually on the backside pulling the air out, and then angle the cooler where you might get a little bit of ram air. That way you kind of get the best of both worlds. You get a little bit from the fan, a little bit from the ram air jamming through. That being said, if space is a constraint and you just need to mount it somewhere where it's convenient, use a more powerful fan and you can really mount it at any angle. And you just have to remember to realize that your fluid is counting on that fan to be operating at all times and drawing the heat out.
Very good. And then we did have a user bring up a good point here. We talked about, do I keep the OEM cooler? Do I eliminate the OEM cooler? Do I switch it out? The comment was, and this is specific to obviously certain vehicles, but if the OEM cooler is being monitored by the vehicle's, onboard computer, and it's looking for that automatic transmission fluid temp, obviously we want to keep the OEM cooler there. So
correct.
We wouldn't want to eliminate it if there's actually a sensor that's being read by the computer. So that's a great comment, and I appreciate that user bringing that up.
100%. Anytime, and as the newer vehicles become more and more sensors, more and more computer-based, more and more electronics, you want to be aware of that, right? Because if you remove a system that has a sensor, you may set a check engine light, which could cause you to fail an inspection if they do that in your area. So that's why we recommend adding our aftermarket cooler maybe in line after the OE. So that way it works in tandem with it to help take that edge off, take a couple more degrees out of the system and really improve your overall cooling.
Very good. I think it goes back to your comment when you were talking in the front of the F-250 over there, that, always checking service information is a great thing, and knowing where all the components are and what they do. So again,
Yes,
thanks for the comment from that user. And Donald, I want to thank you for taking some time out today to speak to the folks that wanted to come in and get some knowledge here. And obviously, if there's any questions, please follow up with us, and we'll be more than glad to help you out any way that we can. And stay tuned, because we do have more Power Hours coming up with more topics, and probably a topic that you're looking to see some more information about as well. So with that, we'll let you all get back to your regularly scheduled day. And thank you again for being here. Have a wonderful day, everyone.